Now let us start again. So here this is the topic which we are going to study today. This is the very important topic in this unit, and this is the last topic of this unit. So as I have told you, so this is nothing but applications to ordinary differential equations. So here we are writing working rule to solve differential equation by Laplace transform. Now we are writing steps here. What are the steps we get here? Let us write step 1. Step 1 is take the Laplace transform of both sides of the given differential equation. This is the first step. Now step 2. In step 2, we write use the formula. Here we have some formulas. Let us write that formulas now. Number 1. Laplace of y dash of t is equal to SL of y minus y of 0. Now second, Laplace of y double dash of t is equal to s square Laplace of y minus sy of 0 minus y dash of 0. Now next, third one, Laplace of y triple dash of t is equal to s cube Laplace of y minus s square y of 0 minus sy dash of 0 minus y double dash of 0. So here we write up to Laplace of y power n of t. So we can write up to Laplace of y power n of t. So now I'm adjusting this. Now after this we can write here, I have written up to Laplace of y triple dash of t. We can write Laplace of y power n of t also. So we use these three formulas mostly in the given problems. Now after this we write step 3. Step 3 is nothing but replace y of 0 comma y dash of 0 comma y double dash of 0 with given initial conditions. Initial conditions will be given in the problem. We will write in whatever initial conditions are given in the given problem. Now this is step 3. Now we write step 4. In step 4 we transpose the terms with minus signs to the right. When we do problem, you can understand what are the steps we have written here. Now step 5. Step 5 is divide divide the coefficient of Laplace of y, comma, getting Laplace of y as a known function of t. Now after this we write step 6. In step 6 we write resolve this function of s obtained in step 5 into partial fractions. Now this is step 6. Now we write step 7. In step 7 we write here, take the inverse Laplace transform of y bar obtained in step 5. This gives y as a function of t which is the required solution of the given equation satisfying the given initial conditions. So these are the steps. We have 7 steps. We will follow these 7 steps to do the problem of this applications to ordinary differential equation using Laplace transform. Now let us have the problem based on this. First problem is, let us have a first problems. So here we write first problem. Just concentrate these problems. These are very important problems. As I have told you, it will give for long question. Write down, using Laplace transform comma, solve d square plus 1 of y is equal to 6 cos 2t. Comma, if y is equal to 3, comma, dy is equal to 1, where t is equal to 0. This is the problem given. Now when a problem is given in this way, now first we write the solution as, first we write what is given. Given equation is what is given here? D square plus 1 of y is equal to 6 cos 2t. Now this can be rewritten as, I can write this as, this is nothing but what, d square y plus y is equal to 6 cos 2t. So this implies I can write, otherwise you can write a step, the equation can be rewritten as y double dash plus y is equal to 6 cos 2t. After writing this one, we have to take Laplace transform. Taking Laplace transform on both sides. Taking Laplace transforms on both sides. If you take Laplace transform on both sides, then this becomes Laplace of y double dash plus Laplace of y is equal to, I can write 6 Laplace of cos 2t. I am writing the constant outside and I am writing Laplace of cos 2t. After writing this, now we have a formulas. Just now I have given the formulas. Laplace of y double dash of t. So here this should be considered as y double dash of t, and this is nothing but Laplace of y of t. Okay, so Laplace of y double dash of t is nothing but s square Laplace of y minus s of y of 0 minus y dash of 0. This is the formula for Laplace of y double dash of t. This is the formula, s square L of y minus s of y of 0 minus y dash of 0 plus L of y, because L of y is L of y only. We will write the same. We don't have any formula for L of y. We have formula for L of y dash of t, L of y double dash of t, L of y triple dash of t, and so on. Okay, so then this is equal to, now here you can write 6 Laplace of cos 2t. As you know, as when you remember Laplace transform of elementary functions formulas, Laplace of cos at is equal to s by s square plus a square. So here a is nothing but 2. So I can write 6 into s upon s square plus 4, because a is nothing but 2. So after writing this, now when you proceed, then this can be written as, now you can see s square L of y, s L of y we have. Now here the initial conditions are given. S of y of 0, s of y of 0 in the sense, here you can see y of 3 is given, where t is equal to 0. This y is also called as y of t, and d of y is nothing but y dash of t is equal to 1. So I can write once again here, I'll write here given initial conditions. For your convenience I am writing here given initial conditions. What is the conditions given? Y of t is equal to what? 3, and here it is given dy is equal to 1. That is nothing but I can write y dash of t. Dy can be written as y dash of t is equal to 1. Here it is given where t is equal to 0. So when t is equal to 0, y of 0 is equal to what? 3. Y dash of 0 is equal to what? 1. Now when you see this, when you substitute y of 0 is equal to 3, y dash of 0 equal to 1, then the equation becomes s square L of y minus s into 3 minus y dash, in the place of y dash of 0 you are substituting 1, plus Laplace of y is equal to 6s upon s square plus 4. Okay, after substituting that, now we take a Laplace of y as common. So when you take Laplace of y common, then this becomes what? S square plus 1 minus s into 3, we can write 3s minus 1 is equal to 6s upon s square plus 4. So after writing this, Now here we have to take this two terms other side, and we have to take this as to other side afterwards. So Laplace of y into s square plus 1 is equal to 6s upon s square plus 4 plus 3s plus 1. Now you can write this as, this is equal to Laplace of y, this s square plus 1 I am taking to other side, that becomes 6s upon, I am writing here s square plus 4 into s square plus 1 plus 3s upon s square plus 1 plus 1 upon s square plus 1. What I am doing here, I am taking this s square plus 1 to other sides, so that it becomes s square plus 4 into s square plus 1 plus 3 upon s square plus 1 plus 1 upon s square plus 1. So after writing this, now you can see here this term can be solved by using partial fraction, as it is given in the step 6. Resolve the function of s obtained in step 5 into partial fraction. So we have to resolve this term in terms of partial fraction, and then we solve the other terms now. So now this is the solution. Now the continuation is there, so let us continue now. So now we resolve this term by using partial fraction. Let us see. So now I write here, now 6s upon s square plus 4 into s square plus 1. We resolve this term by using partial fraction first, and whatever term you get, we substitute here, and then the remaining we solve remaining terms. So there is no need of solving this and this term by using partial fraction. We can use L inverse. When we use L inverse for these two functions, then we get the solution. There is no need of using partial fraction for these two terms. We have to use partial fraction for this term, so that we can substitute there. So now when you use partial fraction for this term, so this is equal to, I can write, as you know, the factors here in the denominator are nothing but in the form of quadratic equation. When you have a quadratic equation, then partial fractions can be taken as as plus b upon s square plus 4 plus cs plus d upon s square plus 1. As we have s here, we are taking s here. If you have x, so we take ax plus b by x square plus 4, cx plus d by x square plus 4. We have s, we are taking s here. Now after this, now as you know, now we take what? We just cancel this denominators by taking LCM here. So you get as plus b into s square plus 1. We cross multiply this, plus cs plus d into s square plus 4. Now we get LCM s square plus 4 by s square plus 1, and the other side we have the same, so we cancel both terms, both LCMs here. So we get this term. Now after getting this terms, we get 6s is equal to, now we multiply with this terms. Now this becomes as cube plus as plus bs square plus b plus cs cube plus 4cs plus ds square plus 4d. So you get this term when you multiply this one. After that, what we do, we compare s cube comma s square comma constants. When you compare all these terms, then we get values of a, b, c, d. So let us see how we get. Now here when you compare s cube term, then the other side we don't have s cube term, so we write 0 first. 0 is equal to, now here on the other side we have s cube coefficients that are nothing but, here s cube coefficient is a, and here s cube coefficient is c, so we write a plus c. And when you see the other terms, we don't have any s cube coefficient, so we write a plus c is equal to 0. A is equal to, you get, minus c. Then after that, when you compare s square coefficient, then you can see on the other side we don't have s square coefficient, so we write 0 is equal to, now here we have s square coefficient, that is b, then we have s square coefficient plus d. Now b plus d is equal to 0, b is equal to, we can write minus d. Now you can take s coefficient also. So s coefficients, if you take on other side, we have s coefficient here. So here we take s, in the place of yes we have 6. Here s coefficient is 6 here, so we write 6 is equal to. Now here on the other side we have s coefficient is a here. Then when you check the other, you have plus 4c, and when you see here we don't have. So now 6 is equal to, now here you can see a is equal to minus c, so you can write minus c plus 4c. Now 6 is equal to 3c, so c is equal to, you get 2. When you get c is equal to 2, then when you put c is equal to 2 in here, then you get a is equal to minus 2. Now after this, when you compare constants, now constants are nothing but, on the other side we have 0 is equal to, now here when you see constants, so we have b here, then after this we have plus 4d, so we can write this as b is equal to minus 4d. Okay, or else instead of writing b plus 4d, we write here, I am writing instead of b, so I am substituting here b is equal to minus d. So when you substitute b is equal to minus d, so minus d plus 4d is equal to 0. So 0 is equal to 3d, d is equal to 0. So when you get 0, when you get d is equal to 0, then automatically b is also 0. So we got a, b, c, d. So this a, b, c, d we substitute here. When you substitute there, this becomes, this is equal to a. In the place of a we substitute minus 2 s plus 0 upon s square plus 4, plus in the place of c we substitute 2s plus d 0, so we write 0 upon s square plus 1. So what are the terms we got here? Minus 2s upon s square plus 4 plus 2s upon s square plus 1. So we got this. Now this term we substitute in the here we substitute. When you substitute, this becomes what? Therefore Laplace of y is equal to minus 2s upon s square plus 4 plus 2s upon s square plus 1 plus, you can see in the place of 6s upon s square plus 4 into s square plus 1 we have substituted that, then plus 3s upon s square plus 1 plus 1 upon s square plus 1, we have to write this. So we write here plus 3s upon s square plus 1 plus 1 upon s square plus 1. After writing this, you can see here this term and this term is same. So I'm sorry, here we have, how we write here now, 2s minus 2s by s square plus 4. This and this terms are same because 2s upon s square plus 1 plus 3s upon s square plus 1. So if you write this, then this becomes 5s upon s square plus 1 then we write minus 2s upon s square plus 4 plus 1 upon s square plus 1. So after writing this, now what we do, we just take Laplace, taking inverse Laplace now. Taking inverse Laplace transform. When you apply inverse Laplace, there is nothing but here, this is L of y, isn't it? So what we do, this L goes to other side, this becomes y is equal to L inverse. So I take 5 L inverse s upon s square plus 1. I take L inverse to all the terms, so that it becomes 5 L inverse s by s square plus 1 minus 2 L inverse s upon s square plus 4, then plus L inverse 1 upon s square plus 1. So after taking this, now as I have told you before, y is nothing but y of t, so we have to take y of t. So y of t is equal to, now when you see the formulas, L inverse of s upon s square plus 1 is nothing but cos t minus, now when you see the formula of L inverse s upon s square plus 4, when you recall the formula, L inverse of s by s square plus a square is nothing but cos at. So now a is nothing but 2 here, so I can write cos 2t, then plus, now when you recall the formula, L inverse of 1 upon s square plus a square, the formula will be 1 by a sin at. So a is nothing but 1 here, 1 by a is nothing but 1 by 1 into sin at. Sin a is nothing but 1, so we write sin t. So this is the answer for the given problem. So in this way we solve the problem when a problem is given from this topic. So this is very easy. So you can be able to solve by using partial fraction, and you have to remember the formulas of Laplace of L, Laplace of y power n, or L of y dash, L of y double dash, L of y triple dash, and so on, and then simplification is needed. So this is the important, and this is very easy. You can score, sometimes it may be asked for 10 marks and sometimes it may be asked for 5 marks. So hope you have understood. Let us go for the next problem. Next problem is second problem. Use Laplace transform. Use Laplace transform to solve y dash minus y is equal to e power t given y of 0 is equal to 1. Y of 0 is equal to 1. So this is the problem given. Now when a problem is given in this way, as I have told you just now, in the previous problem it was d square plus 1 into y. Here it is given directly y dash minus y is equal to e power t given y of 0 is equal to 1. Now let us write the solution. So when you write the solution, first we write given. So given y dash minus y is equal to e power t. After writing that, first we take Laplace on both sides, taking Laplace transform on both sides. So when you apply Laplace transform, we separately we apply Laplace of y dash minus Laplace of y is equal to Laplace of e power t. After applying this, now we use the formula Laplace of y dash. As you know, Laplace of y dash is nothing but s L of y minus y of 0. This is the formula for Laplace of y dash. Minus Laplace of y here is given, so we write same as it is, Laplace of y is equal to, now when you recall Laplace of e power at. We discussed in the first topic when we have started this unit. Laplace of e power at is nothing but 1 by s minus a. So when you see in this problem, it is given e power t. So e power at, it should be e power at. A is 1 here. So I can write 1 upon s minus 1. After writing that, after writing this, now when you take Laplace of y common, then this becomes what? S minus 1, because Laplace of y into s is this one. Then Laplace of y into 1 is this one. Now minus, now y of 0 is given in the question, that is initial condition, that is 1. So we write 1. That is equal to 1 upon s minus 1. So after writing that, now we take this minus 1 to other side. When you take this minus 1 to other side, this becomes Laplace of y into s minus 1 is equal to 1 upon s minus 1. I take this minus 1 to other side, that becomes plus 1. After writing plus 1, now we take this s minus 1 to other side, a denominator of these two terms, then this becomes Laplace of y is equal to 1 upon s minus 1 whole square plus 1 upon s minus 1. I am taking this s minus 1 to the denominator of s minus 1 here, so this becomes s minus 1 whole square. Again we will take 1 upon s minus 1. After taking this, now we can write this as, so before doing this, you do one thing. This is equal to, just take this as 1 by 1. Now cross multiply this. When you cross multiply this, you get 1 plus s minus 1 upon s minus 1. So you write in this way. So after writing that, you will get the term here, 1 and 1 get cancels, only s upon s minus 1 will be there. So you get the term. So you just you write this term as, I just cancel this term, whole terms. Now you get Laplace of y of s minus 1, s minus 1 is equal to s upon s minus 1. This term same I am writing here. Laplace of y is equal to, Laplace of y into s minus 1 is equal to s upon s minus 1. Now this becomes what? Laplace of y, this term I am taking to denominator of this one, so this becomes s upon s minus 1 whole square. Now I'll take now inverse, taking inverse Laplace transform. When you take inverse Laplace transform, then this becomes what? L goes to other side, so this becomes y of t, y or y of t. Instead of y, you can write y of t, or y of t, instead of y of t you are writing y here. So y of t is equal to L inverse, so we write here s upon s minus 1 whole square. So after writing this, now what we have to do is, this is equal to L inverse, I have to multiply, I have to subtract and add with 1. So I am adding and subtracting with 1 here, s minus 1 plus 1 upon s minus 1 whole square. So after this, what you do, then you write this as y of t is equal to, now this has become as in the form of a shifting theorem of inverse Laplace. This is in the form of L inverse e power at into f bar s plus into f bar s. So I am writing e power t L inverse s plus 1 upon s square. As I have discussed in the previous class, inverse Laplace, that is nothing but L inverse of e power at into f bar s. So we have taken here in this way. So this is in the form of, this term is in the form of a shifting theorem of inverse Laplace. So s is here, this is in the form of s changes to s minus 1. So I have written in the form of e power t L inverse s plus 1. Instead of s minus 1, we have to write s here plus 1 here. Instead of s minus 1, we have to write s, because we have taken already e power at. So after taking this, now this can be written as e power t, then put box, then write L inverse, and here you can write s upon s square. Just separate the terms here now. S upon s square plus 1 upon L inverse of 1 upon s square. Now close the bracket, just separating the terms. Then after this you can write y of t is equal to e power t, okay, e power t L inverse of, now you can see s get cancelled, so you get in box L inverse 1 upon s plus L inverse 1 upon s square. Now put the box. Now here we have a formula. What formula we have here? E power t L inverse of 1 by s is nothing but 1 plus, now L inverse of 1 upon s square, that is L inverse of 1 by s power n, that is nothing but t power n minus 1 by n minus 1 factorial. So when you apply the formula, you get t. Which formula I am using here? L inverse of 1 upon s power n formula I am applying here, that is nothing but t power n minus 1 by n minus 1 factorial. This is the formula I am using for L inverse of s square. Now here you can see this is in this form. So yeah, in the place of n we have 2. So when you substitute here t power 2 minus 1, that becomes t upon 2 minus 1 factorial, that becomes 1 factorial. So we get only t. So this is the solution for the given problem. So it's concluded that we can do the problem by using, instead in between we use partial fraction, we use for shifting theorem. In this problem we use for shifting theorem of inverse Laplace. Okay, so by taking this all we use. The thing is, when you practice, when you go through all the topics, then only you can able to do this problem, or otherwise when you just verify some of the problems, then it will be difficult for you. So Laplace transform is the topic where you have to cover all the topics, so that maybe which formula we use, where you can see we have used Laplace transform elementary functions formulas also here. Now this is the second problem. Now let us have third problem. Let us see how we do third problem now. Third problem is, let us write third problem. Solve y double dash plus y is equal to 2 e power t, comma y of 0 is equal to 0, comma y dash of 0 is equal to 2 by using Laplace transform. By using Laplace transform. This is the problem. Now let us do the problem based on this. Now we are writing the solution. First we write given. So here given is nothing but y double dash plus y is equal to 2 e power t. Then after this we take, first what we do, taking Laplace transform on both sides. So when you apply Laplace transform on both sides, then this becomes Laplace of y double dash plus Laplace of y double dash plus Laplace of y is equal to 2 Laplace of e power t. Now when you apply this, on both sides we dash. You know the formula is nothing but s square Laplace of y minus s y of 0 minus y dash of 0 plus Laplace of y is equal to 2 into, just now we have written Laplace of e power at is nothing but 1 upon s minus a, that is 1 here, so we write 1 by s minus 1. So this is the formula we apply here. So after writing that, now we apply initial conditions. What are the initial conditions? Let us see. S square L of y minus y of 0 is given 0, so we write 0 here. Y dash of 0 is 2, so we write 2 here, plus Laplace of y is equal to 2 upon s minus 1. So after writing this, now we take L of y common. L of y, if you take common, then this becomes s square plus 1, and this minus 2 I take to other side, that becomes 2 upon s minus 1 plus 2. After taking that, then now as I have told you in the previous, just after writing s square plus 1, you just write this by 1 and just simplify this term, cross multiply this, so then this becomes 2 plus 2 into s minus 1 becomes 2s minus 2 upon denominator is s minus 1. Okay, so after writing this becomes Laplace of y into s square plus 1 is equal to, now here you can cancel 2, so when you cancel 2 you get 2s upon s minus 1. So this implies I can write Laplace of y is equal to 2s upon s minus 1 into s square plus 1. What I am doing here? I am taking coefficient of s square Laplace of y to the denominator of this term. So this becomes 2s upon 2s upon s minus 1 into s square plus 1. So after writing this, now you take this as equation 1. So after taking equation 1, now what I do, I take L inverse of 1 upon, I use convolution theorem here. How? Here I take, as you know, L of y, we take just y of t is equal to, when you apply L inverse on to other side, that is nothing but taking inverse Laplace to the term, then what we get, L inverse of 2s upon s minus 1 into s square plus 1. For this term, what we do, I write L inverse 1 upon s minus 1 into s square plus 1, and I apply there's nothing but convolution theorem, there's nothing but L inverse of f bar s into g bar s is equal to what? Integral 0 to t f of u into g of t minus u du. So it concludes that we can use convolution theorem, either we use partial fraction or we use first shifting theorem also. So now we take f of u. What is f of u here? F of u is equal to, instead of finding that, that's nothing but first we have to find what is 1 by s minus 1, L inverse, that's nothing but I have told you just now. F bar s is equal to 1 upon s minus 1. So we have to apply L inverse for f bar s, that is L inverse of s minus 1 is equal to L inverse of s minus 1 is equal to e power t. So L inverse of this is nothing but what? I am taking this is as g of u, or otherwise g of t. Then I am writing g bar s is equal to 1 upon s square, or otherwise here we have as you have seen here we have s here. Yes, you take s s upon this 2 just exclude, we write after finding all we just include the 2 here. Just we are taking s upon s minus 1 into s square plus 1. So L inverse of s by s minus 1 into s square plus 1 we are writing in terms of convolution theorem, and we have taken f bar s as 1 upon s minus 1 and g bar s is equal to s upon s square plus 1. Now when you apply L inverse to g bar s, that is s by s square plus 1, so you have a formula that is nothing but L inverse of s by s square plus a square is nothing but cos at. Here a is 1, so I can write cos t. Now this I am writing as f of t. So now we want g of t minus u. So g of t minus u can be written as e power t minus u. Now f of t already we have. Now f of u is equal to cos u. So one of you have asked why can't we do by partial fraction? We can do by partial fraction. So I'll do one thing. When I send notes, in that I'll do by using partial fraction. So here as I have already started, so let us complete by using this uh, convolution theorem. So I'll send notes by using partial fraction. I'll do the problem and I'll send you. So let us complete this by using convolution theorem here. Now we got g of t minus u, f of u. Okay. So now directly we substitute now. So when you substitute here, L inverse of s upon s minus 1 into s square plus 1. So this is equal to, as I have told you, integral 0 to t f of u g of t minus u du. Now when you apply here, this is equal to integral 0 to t f of u is nothing but cos u into g of t minus u is nothing but e power t minus u into du. So after this, now when you have completed this, that's nothing but in the place of f of u we have substituted cos u. In the place of g of t minus u we have substituted e power t minus u into du. After substituting this, let us complete this problem in the next page. Now when we take this, now we have this is equal to, I'll write this step once again so that you can understand. This is nothing but we have written in the back, that is integral 0 to t cos u into e power t minus u into du. After writing that, we are writing here this is equal to integral 0 to t cos u into e power t into e power minus u du. That is basis same power should be added, so I am just separating this e power t minus u as e power t into e power minus u. After separating that, I take common e power t. If you take e power t common, then this becomes integral 0 to t, then e power minus u I am writing first, then cos u and then du. Now this is in the form of, we have a formula that is nothing but integral 0 integral e power ax into cos bx dx is equal to e power ax upon a square plus b square into a cos bx plus b sin bx. This is the formula we are using now here. This is in the form of, here you can see in this problem a is equal to minus 1, b is equal to, you can see 1, because ax, instead of x we have u here. You can see ax cos bx dx. Instead of x we have u here. So a is minus 1 here, b is equal to 1. Now when you apply in this formula, let us see what it becomes. So this is equal to e power t. Now here limits are 0 to t here. We have to take the limits. Now e power, when you are applying the formula, so let us just apply the formula and then apply the limits here. Now in bracket we have to write e power ax. Ax is nothing but, a is minus 1, x is nothing but u, so we write minus u upon, now a is nothing but again minus 1 whole square plus 1 whole square. Then we write here a is nothing but minus 1. So minus cos bx is nothing but b is 1, x is u here. Then plus, then b is 1 sine b is 1 again, we write u. Then after writing this, just close the bracket and apply the limit 0 to t. So after applying that, this is equal to e power t, and then when you apply limits to u, this upper limit and lower limit we have to apply to u. So when you apply to u, this becomes e power minus t upon 2. Then here when we are applying upper limit, so in the place of u we have to write t. So minus cos t plus sin t. So this is upper limit. So upper limit is over. Now minus lower limit. Lower limit, when you apply 0 to u, e power 0, that becomes 1 upon 1 plus 1 is 2. So you know that. So we have taken here also. Okay. So then afterwards, in bracket, now when you apply 0 to u here, so this becomes cos 0. Cos 0 is 1. So that becomes minus 1 plus. Now when you apply 0 to sin u, that becomes sin 0. Sin 0 is 0. So afterwards, this is equal to e power t in bracket. We have to write this as e power minus t upon 2, and then minus cos t. This is same. I am writing here. After writing this, just to simplify this term, this becomes minus of minus plus 1 by 2. So after writing this, now you multiply e power t inside to both the terms, then this becomes t into e power minus t upon 2, and in bracket you write down minus cos t plus sin t. After writing that plus, now you multiply e power t to with 1 by 2, that becomes e power t upon 2. So after writing that, this becomes e power t minus t, that becomes e power 0 upon 2. Now I write positive term first, that becomes sin t minus cos t plus e power t upon 2. Now this is equal to 1 upon 2 sin t minus cos t plus e power t upon 2. Now so we got this term. We have to write here in equation 1. Here you can see in equation 1, here one step we include here. This is nothing but y of t is equal to 2 into L inverse of s upon s minus 1 into s square plus 1. Now this is equation 1. You can see y, this L goes other side, so that becomes 2 into L inverse s upon s minus 1 into s square plus 1. So after that, so when you substitute in equation 1, you get y of t is equal to 2 into 1 upon 2, because for both the terms we have 1 by 2. So 1 by 2, and then in bracket you write down sin t minus cos t, then plus e power t. Just close the bracket. Now cancel 2. So this becomes in bracket sin t minus cos t plus e power t. So this is nothing but y of t. This is the solution for the given problem. Hope you have understood the problem. Now let us have so now this is already 4. Now we have completed this topic. Now we have done 3 problems. More problems we have. If you want, you just WhatsApp me. I'll just send you the solutions as well as questions so that you can do at home. Now we'll start fourth unit. We have to start 4th unit. Let us start 4th unit. I'll take class tomorrow. Please be with me by 3 o'clock tomorrow. Okay, thank you. You can send attendance now. So these are the 3 problems we have done today. This is very important topic. You just practice these problems. If you want, I'll send more problems. Thank you. Please post your attendance. I'll take tomorrow at 3 o'clock. I'll start fourth unit tomorrow. This is the one topic we have taken. As I have told you, I'll take 3 to 4. So it's 4 now. So let us wind up now.